We know that gravitational force is everywhere and is inversely proportional to the square of the distance between two masses. Here I am giving a brief calculation of the ratio of the magnitudes of gravitational force and the electrostatic force, or the ratio of electrostatic force to the gravitational force between two protons in a nucleus. So let's calculate the electrostatic force between two protons and the gravitational force between two protons in a nucleus and their ratio. Okay, so the ratio of Fe, the force or the electrostatic force, to Fg, which is the gravitational force in the nucleus of an atom between two protons. Okay, so this is Fg, which is the gravitational force between two protons. Okay, these are Fe and Fg for simplicity I've taken here. Mp is the mass of a proton, which is about 1.67 times 10 to the minus 27 kgs, and Me, or we can write it positive E, the charge on a proton, while negative E would be the charge on an electron. Both are equal and opposite. So it is positive 1.6 times 10 to the minus 19 Coulomb. If we use Coulomb's law for electrostatics, we can calculate the force or the electrostatic force between two protons, and we know that it is repulsive, okay, because both protons are of the same charge, so they would repel each other. So the force or the electrostatic force equal to K times into E times E divided by R squared, where R is the distance between the two charges. And here in this case this R is equal to, or R is of the order of 10 to the minus 15, which is in Fermi's. Oh my god, I think this ant wants to learn something in physics I'm doing here. Perhaps. And this electrostatic force Fe is equal to 9 into 10 to the 9 times charge on an electron, or we can write E squared, or 1.6 times 10 to the minus 19 to the square divided by R squared, which is, we know that the force is inversely proportional to the square of the distance between the charges. And the same rule is followed for gravitational force. So here the gravitational force F of G is equal to G times MP times MP, or G times MP over R squared. The value of G, we know that it is a 6.673 times 10 to the minus 11 times mass of proton, which is 1.67 into 10 to the minus 27 kgs, and it is squared over R squared. I'm writing just R squared because when we will divide both of these equations, so this R squared will be cancelled out, and Fe over Fg would be equals and would be equal to K times E squared over G times MP squared. If you write values of K, which is 9 times 10 to the 9 times 1.6 into 10 to the minus 19, and it's squared, and the whole divided by G, which is 6.673 times 10 to the minus 11 multiplied by MP, which is 1.673 times 10 to the minus 27, and it is squared. I'm using my calculator to solve it, and the value is 1.23 times 10 to the 36. It means the gravitational force is very weak, or we can say that the electrostatic force between two protons in a nucleus is tremendously large when we compare it with the gravitational force of two protons in a nucleus. And one thing we have to notice here, that the gravitational force is attractive everywhere between two masses in the universe, and the electrostatic force in this case is repulsive because both the charges are of the same kind. We know that like charges repel each other. Thank you so much. If you want some more videos like this one, stay tuned. Have a great day. Take care. Bye bye.